Use the part drawing images shown to build this part in SolidWorks. Unit system inches, decimal places 2, part origin arbitrary, and material nickel. This is the second example for the how to use reference geometries main video. If you haven't watched that 9-minute video yet, or the first example, you can find the links to those in the description below. Links to other lectures and examples are also found in the description of this video. Just like in the previous example, we'll begin by creating the rectangular prism with its 3 and 5.5 inches dimensions. Only this time we include the 2-inch diameter circle in the top plane sketch, 1.5 inches from the top and right sides of the rectangle, and we add a 1.5 radius sketch fillet to the bottom right corner. And by the way, we'll go a lot quicker with features that were already covered in the first example and the main lecture video, so watch those first if you haven't already. Just like in example 1, each one of the arguably 3 distinct features can be created in any order. From front to back, we'll begin with the chopped off corner. We draw a center line on the front plane that starts 1.5 inches from the vertical line and ends 1 inch below the top surface. We use that line and the intersection point between the fillet and the right side to create a reference plane. After creating the reference plane, we hide the center line. In order to remove that chunk of material, we need more than just a triangle as opposed to the previous example. So here, any sketch bigger than that chunk will do. For example, a big circle. Just make sure to fully define it, whatever it is. Of course, you can make it more elegant, but this will suffice here. We use that as a sketch of an extruded cut. We set the direction outward and through all. Just like in the previous example, the 2 holes coming out of the back have a radius of 0.25 inches in the z-axis when looked at from the top, and a radius of 0.20 inches in the perpendicular direction when looked at from the front. Therefore, those 2 holes are ellipses, not circles. We create a reference plane 50 degrees between it and the top plane as seen from the front. Remember your corresponding angles and complementary angle rules. We draw 2 ellipses with those radii values I just mentioned equal to each other, 0.55 inches from the sides, 0.5 inches from the edge of the prism, and fully defined with either a vertical or a horizontal constraint between one of their cardinal points and their center so that they don't rotate. And we extrude cut the sketch through all. And finally, we need a circular hole. Circular because we see the true radius 0.20 annotation on it that starts at the top and ends where the big vertical hole is found. We see that the center of the hole, and therefore a point we can draw on the top plane, is located 1 inch from the left and 1.5 inches from the bottom. The reference plane that we need to sketch the circle makes a 70-degree angle with the top plane as seen from the front. And again, remember your corresponding and complementary angle rules. And we draw a circle using the point we just sketched as its center and define its radius as 0.20 inches. We use that to create an extruded cut, in this case up to next, so that the hole stops when it has cut through the first continuous volume of the material. We hide the plane and the sketch of the point, assign the nickel material, and we are done. The links to more CSWA type examples as well as the main 10-minute lecture videos of the SolidWorks course are found in the description below, so make sure to check them out. Thanks for watching!